video, I am going to explain you AC circuit consisting of pure capacitor only. Consider one AC circuit consisting of capacitor of C farad supplied with AC voltage of V volts. V is equal to Vm sin omega t. A current of I amperes starts flowing in this circuit, because of which a charge of Q coulombs start getting accumulated on the capacitor plates. This charge Q is equal to C into V, where C is the capacitance of the capacitor. Now V is equal to Vm sin omega t. So substituting this, we get the expression of Q as Q is equal to C Vm sin omega t. Now we want to find out the current flowing in the circuit. This current is equal to rate of flow of charge with respect to time. I is equal to dq by dt. So let us substitute the expression of Q in the equation of I. So I is equal to d by dt of CVm sin omega t. If we differentiate this expression of Q with respect to time t, we get the expression of instantaneous value of current. So I is equal to dq by dt is equal to d by dt of CVm sin omega t. We know that the derivative of sin omega t can be written as omega into cos omega t. C and Vm are constants. So we can write I is equal to C Vm omega into cos omega t. Therefore, I is equal to Vm upon 1 upon omega c multiplied by sin of omega t plus pi by 2. Here we have substituted cos omega t as sin omega t plus pi by 2. Now, Vm upon 1 upon omega c can be written as Im. So, Im is equal to Vm upon 1 upon omega c. If we divide both the sides of this expression by root 2, we get the equation for RMS value of current. I is equal to V upon 1 upon omega c. This 1 upon omega c can be written as Xc, the capacitive reactance. This capacitive reactance Xc is equal to 1 upon omega c, which is equal to 1 upon 2 pi Fc. This is the opposition to the flow of current in purely capacitive circuit. It is measured in ohm. Now, if you substitute this Xc in the equation of I, we get I is equal to Im into sin omega t plus pi by 2. Here we have got two equations which are alternating equations. One is V is equal to Vm sin omega t and I is equal to Im sin omega t plus pi by 2. If we plot these two equations with respect to theta, we get the graphical representation of voltage and current. It can be observed that voltage has 0 value at theta equal to 0, whereas the current was 0 at minus pi by 2 radians. This indicates that the current is leading the voltage by pi by 2 radians or 90 degrees. This is also reflected in the phasor diagram, which is drawn with voltage as reference and current is shown leading this voltage by 90 degrees. Now let us derive the equation for instantaneous and average value of power supplied to the capacitor. We know that instantaneous power is given equal to the product of instantaneous voltage and instantaneous current flowing through the capacitor circuit. Now for this, let us see the waveform of voltage and current flowing through the purely capacitive circuit. Here it can be seen that at theta equal to 0, voltage is 0. At theta equal to pi by 2, current is 0. Again at theta equal to pi, voltage is 0. At theta equal to 3 pi by 2, current is 0. That means at all these points, the product of voltage and current, that is the instantaneous power, is going to be 0. Between 0 to pi by 2, voltage and current both are positive. Because of this, the product, that is power, is going to be positive. Between pi by 2 to pi, voltage is positive but current is negative. So the instantaneous power is going to be negative. Again between pi to 3 pi by 2, voltage and current both are negative, so the product is going to be positive. Between 3 pi by 2 to 2 pi, voltage is negative and current is positive. So again the product, that is instantaneous power, is going to be negative. It can be seen that for half cycle duration the power is positive and for remaining half cycle duration the power is negative. Positive power means the power flows from source to load, that is to the capacitor, and negative power means the power is flowing from load to source. That means capacitor is a device which accepts power for half cycle duration and gives it back to the supply for remaining half cycle duration. So it is a device which doesn't consume power, it accepts power, stores it and gives it back to the supply. Now mathematically we can write instantaneous power equal to the product of instantaneous voltage and instantaneous current. Let us substitute the expressions for instantaneous voltage and current in this. We will get instantaneous power equal to Vm sin omega t multiplied by Im sin omega t plus pi by 2. This is equal to Vm Im sin omega t cos omega t. This product sin omega t into cos omega t can be written as sin 2 omega t divided by 2. So instantaneous power is equal to Vm Im upon 2 into sin omega t. In order to find out average power, we will have to integrate this expression over one complete cycle. And as this term has a double frequency component, because of this, the average power, that is integration, will be 0, which shows that capacitor doesn't consume power, it only accepts power and gives it back to the supply.